Hello students, my name is Shashank Shekhar. So today we'll start a new chapter, that is structure of atom, right? So this chapter will mainly deal with kind of the development of the atoms, right? You will see that how this atoms were developed, how we came to know that yes, we have electron, we have proton, we have neutron and all. Then we'll talk about their complexities, like what is their mass and charge. So we will talk about all of this, right? So it is important to study this chapter so that if you are in future interested in research and all, then you can think of the way that they have thought of, right? So it's just an abstract thing, but basically it gives you an idea that how you can think of, right? So this is a very fascinating and exploring kind of thing. So we'll start this, right? If I talk about the most primitive atomic structure that was being put up, so I would be very bad to say that primitive. I would say that the first that was to be set up was given by the Dalton's atomic theory that we studied. So although it was not that much good to explain most of the thing, but still we got a good start from there. Then the atomic structure key points were like this: that okay, atoms are the indivisible particle, they cannot be divided further and all. But later on we found that yes, it can be indivisible. Atoms are instead made up of electron, proton and neutron and all. So there is a kind of drawback that came after that atomic theory. Clear? So we'll study about those electrons, protons and neutrons, as I've said, and also their arrangement. So how are these electrons, protons and are arranged in atoms? How this neutron is in the center, and why this electrons are in different stationary states and all. So let us start our class with this thing in our mind. So the rich diversity of chemical behavior of different elements can be traced to the difference in internal structure of this element. The existence of atoms has been proposed since the time of early India and Greek philosophers. So this is a very interesting point, that not only Dalton from Greek got the idea of atomic, but in India also we have some philosophy, right? So initially science was more of a philosophy rather than the scientific world we see today. But still, philosophy is the you can say it has given birth to science, because first we have thought of a thing, then it is experimentally verified, and then we conclude get at the reason, right? So philosophy, you can think that it is the mother of your science. So initially we don't have scientists like we have today. We have philosophers like Greek philosophers, which are Aristotle and all. They were very popular in their times for their thoughts. Similarly, we have in India also very philosophers which kind of gave this theory of the atomic, and they were called as atomio, right? Okay. So with this we have got a start point. So the atomic theory, as I have told, was first given by John Dalton, who was a British school teacher in 1808, and his theory was called as Dalton's atomic theory, right? And he called it as ultimate particle of matter. Atom as the ultimate particle means it is the last particle that you can think of. Means if you just go on cutting suppose an element, if you go on cutting an element, if you go on doing it again and again, then after some time you will reach at a point where you cannot cut it further, and that particle which you got at the last, that you call that yes, I cannot cut it further, then we call that particle as atom. Clear? So with the help of this atomic theory, although it has drawbacks, but it was able to explain the law of conservation of mass, because you have told that okay, atom is a fixed thing, now you cannot break it further, so the mass is a kind of conserved in that atom. It's clear? Similarly, law of constant composition and law of multiple proportion. So you must have studied all these three laws in the first chapter. So this all laws were totally explainable with the help of this Dalton's atomic theory. But as the new particles, like which we call it as subatomic particle, with the particles which are present inside the atom, so they are called as subatomic particle, and they were electron, proton and neutron. And this concept was totally different from that of the Dalton. So how was it discovered? What was the reason behind it? So the reason behind it was the discharge experiment. Okay, electrical discharge experiment. So this is the very famous experiment. You must have heard it to and fro about this experiment. So yes, that was the key point, or you can say that was the factor that told us, okay, that we can't go with this atom. Okay, we can't go with this atomic theory, that we don't have any further particles, but we have. So we have the electron that are giving the discharge. So with the with this concept in our mind, with the say electrical discharge experiment, J.J. Thomson, who discovered this negatively charged particle called electron, he gave his theory about the atoms, that okay, we have a sphere. You can think of the atom like this, in this way, that we have a watermelon. So the red part, which is present in most of the region, will be positively charged. So it is a kind of embed, right? So this, and the embedded seeds that you see are the electrons. So again, this was the first theory. So he compared atoms with the half-cutted watermelon, or you can think of the Christmas pudding model. You have heard this term, pudding model, right? So in this, we have cherry and all as the electron, and the cream which is present, that will be considered as a bed of the electron, sorry, proton, or the positive charge. Okay, now later on, after J.J. Thomson, Robert Millikan, who was a very famous scientist, he discovered the mass and charge of the electron with the help of his famous Millikan's oil drop experiment. And after that, the twist came when Rutherford came with his model of atom, in which he said that, okay, here is a twist for you, that we can't go with this model that the electrons are present as a, say, you can say that, as are embedded on the positive charge, and positive charge is all over the atom. So this was crushed by his experiment, which is known as gold foil experiment, his famous gold foil experiment, which crushed the theory of J.J. Thomson that positive charges spreaded all over the atom. Clear? Okay. Now, first we will talk about this electrical discharge theory. What was this experiment? What it did in this experiment? So we will talk about this first. So it started with the Michael Faraday experiment. It was not the J.J. Thomson experiment finally. It was the final call. But before that, Michael Faraday has done this experiment. What he did, he passed electricity through an electrolyte solution, okay, which caused chemical reaction at the electrode, resulting in the liberation and deposition of matter. This suggested that the particulate nature of electricity. So what he did, with the help of electricity, he caused some chemical reaction. So it started with Michael Faraday in 1830. Then in the mid 1850, he began starting with he did the same thing. So which he initially did with a chemical, he did the same thing with an evacuated tube, right? He took a evacuated tube, which is known as cathode ray discharge tube, and then he did that experiment. And this tube shows that the electron flow from negative electrode to the positive electron when a highly sufficient voltage is applied. So it is very unique. So just think of it in a way that you are in a vacuum, means only some amount of gas is present. There is a canal like thing, and only gas is present there, and across the canal you are applying high voltage, and then you are saying that although there is vacuum, there is only some air present there. I would not call it volume. There is a only air present there, but still we are detecting electric current. Okay, so the circuit is incomplete. We don't have any wire through the canal. There is completely air present inside it, but on applying high voltage, we are seeing that, okay, we are able to conduct electricity. So this you kind of just picked off this thing, right? That okay, we can do this. Okay, just there is something which is conducting electricity, and it was seen that they were stream of particles. Okay, they were stream of particles, which we call them as cathode rays or cathode ray particles. Okay, we call them as cathode ray particles. Clear? Okay, got it. So we will talk about this. How does one detected this particle? So they were not visible. Okay, the current was flowing. There were some particles, some stream of particles that must be responsible for this current. So this is the thing. So this is our experiment. We are applying high voltage. across this vacuum tube. Okay, there is some amount of gas present, so there is a vacuum pump that is in decreasing the amount of gas here. Now you can see that the electricity is being passing here. So for detecting this, what they did is to detect this say stream of particles, what they did is they take a perforated, this is called perforated, means there are holes present or pores present here in this anode. Now we have a kind of fluorescent substance here. Fluorescent substance are those which can show color upon excitement. Means if they're given enough energy, then they will do a transition and they will come back and release that same amount of energy in the form of what? In the form of electromagnetic radiation that falls in the visible region. So what we did first, we do take a anode which is having pores here, and the current is made to flow with high voltage that resulted in a stream of particles which passed through these pores and hit this phosphorus coating, right? And due to that reason, this phosphorus coating got enlightened, and this kind of indicated that yes, something is there which is kind of providing energy to this fluorescence coating. So with this, we came to the point that atom is not the only thing. The atom is getting ionized. Here's what is happening. The atom is getting ionized, means it is releasing its electron. It is releasing its electron. The gas which is present there must be made up of atoms, and those atoms, upon applying high voltage, they are releasing electron. Clear? And those electrons are called as stream of particles. Okay, and those stream of particles hit that the fluorescence coating, which gave us the idea that okay, we have some particles inside the atom also. Now this is about the cathode rays. Now cathode rays start from, if you talk about some key observations, so what are the key observations regarding this cathode rays? So you can see very clearly here that they must be moving, since it is negative charge. So it is, if you are getting this thing here, this fluorescence coating here, so it means that it must be starting from this negative charge, emitting from the negative charge and moving towards the positive charge. So I'm not saying that electrons are coming here and just coming out of the wire and moving all over area. Instead of that, what is happening? The gas, that is small amount of gas that is present here, due to high voltage, the electrons are getting enough energy to come out of the atom and move through this canal, because it is positively charged. So these electrons will be attracted here and they will strike this surface. So they are moving from cathode side to the anode side, not from cathode to anode, but from cathode side to anode side. Clear? Okay. Now they are not visible. Of course, they are not visible. For observing them, we have done the phosphorus coating so that their effect can be observed. Now in the absence of electrical or magnetic field, cathode rays travel in a straight line. Okay, so this is very important point, that if there is nothing present there, then they will totally travel in a straight line. But if there is electrical or magnetic field, then we can see the deflection. Okay, now this deflection defines that okay, we have some charge on it. This deflection is also a kind of indicator that we have some charge on it. So how do we deflected it? With the help of electric and magnetic field. So we'll see how we deflected it. Now cathode rays characteristic does not depend on the electrode material or the gas in the tube. Means that particles that are being emitted from the gas are independent of the gaseous particle that we have used. Okay, means whatever gas we used, the particles the nature of the particle were not changing, that were traveling through the tube. And this kind of push that okay, there is something very fundamental to the atom. Okay, so it is not varying from atom to atom, but the same property is seen throughout all gases, right? Clear? Now the electrical discharge carried out in the modified cathode tube led to the discovery of canal rays, and these rays that we are talking about, that the stream of particles, we call them as canal rays. Clear? Okay, so these are about the canal rays. Okay, this is about the proton. Sorry for that. We'll talk about it later. Okay, so this is modified cathode ray tube. Okay, so we'll talk about this. Now we need to get some more idea about. Okay, so it is some particle is there, so we got that. Okay, so now we need more idea about it. So what is the charge on it? What is the mass of it? We need to characterize it. So for that, what we did is we applied a electrical and magnetic field perpendicular to each other, right? So kind of this. Okay, so if the cathode ray is in between, then we provided two so here electrical field and magnetic field in the perpendicular direction, right? So suppose here is the north south. Okay, so it is our electrical way. Okay, so this is the electrical potential that we are applying. So perpendicular to that potential, we applied the magnetic way. Now we did it in a way so that they can be deflected. Okay, they can be deflected. So it was all done to calculate the charges to mass ratio. So this is the kind of thing that we are talking about. Suppose this is the magnet. Okay, this is the magnet, and this is the field that we are applying. Clear? This is the electrical field. You can see that it is from up to down, positive to negative, and the magnetic field is in this way, vertical, horizontal direction. So south to north. Now what we are doing is we are kind of balancing them out. So suppose in the presence of only magnetic field, so if you just put it in magnetic field, then this rays will get deflected. Again, if you put only the electrical field, then again it will get deflected. Now what we are doing, we are applying both field and we are balancing it further. I'm not saying that only in the presence, so if you just present the electrical and magnetic field, it will go straight. We have to balance this in such a way that it goes in a straight line. So we did a balance between the electrical field and magnetic field, and due to that reason it goes in a straight line. And with the help of that potential that we have to apply and the magnetic field that we have to apply to just make it a straight line rather than a deflecting point, so you can see that it get deflected also, we calculated the charge is to mass ratio. Okay, we calculated the charge is to mass ratio. Clear? So the same thing is mentioned, when only magnetic field applied, it deviates from their path and it hit the cathode ray tube at point A. So this is a very important point. So if we just provided this electrical field, this is getting deflected towards upside. So what can be the cause of it? Now you can see that this blue kind of electrode is positively charged. Means this particle is going upside, or you can say that it is getting attracted to this positively charged because this is also present upside. So from this we can conclude that okay, this ray tube is having a negative charge. So this is a kind of observation they made. Next is, similarly, when only magnetic field is applied, it strikes the cathode ray at point C. So this is the point C if only magnetic field is applied. So it is in totally accordance with the electromagnetic induction. You must have heard that the right finger rule and all, that right hand rule and all, that in the presence of a magnetic field, the electrical charges gets deflected, and that happens in the opposite direction. So if this is positive, this is negative. So these things are also very important. The upside we have positive, downside we have negative. Here we have north, here we have south. Clear? Okay, so by carefully balancing this field, it is possible to bring back to the electron to the path that is point B. Clear? Okay. Now, with the help of this deviation and all, he calculated the ratio. Now the magnitude of the negative charge on the particle is greater than the magnitude of the charge on the particle. Greater is the interaction with the electric or magnetic field, thus greater is the interaction. So what does this mean? So as we are increasing or decreasing the charge, or as we are increasing or decreasing the potential, increasing or decreasing the magnetic field, we are seeing a change in the deflection. Means these particles are charged. Okay, these particles are charged, and more clear opinion would be that it is negatively charged because it is getting attracted to the positive charge. Okay. Now the mass of the particle is lighter than the particle, greater the deflection. So the second thing is that if the particle is having a lighter mass, it will get deflected more. Okay, this is obvious. So if you want to move a heavy thing, then you have to apply more force. Now if you want to move a lighter thing, you have to provide less force. So it was seen that a very light field was able to do so. Means the charge, the mass is very small. The strength of the electric and magnetic field, the deflection of the and then the third thing is the strength of magnetic and electric field. The deflection of the electron from its original path increases with its voltage. So same thing is written here. Clear? So these are the 3 points. Now, as I have told, they balance this electrical and magnetic field such that there is no deflection, and that ratio comes out to be 1.758820 into 10 to the power 11 coulomb per kg. Why coulomb per kg? Charge per mass. Okay, so the charge has a unit of coulomb and mass as a unit of kg. So that comes out to be coulomb per kg. And this is the what? This is the charges to mass ratio. Clear? Where the mass is in kg and the charge is in coulomb. Now we are still not aware what is this mass. So once we got this mass or either we got this charge, we can calculate both of them because our ratio is known now for that reason. So for that, the hero that comes out was Millikan. Okay, he devised a method which is known as oil drop experiment, and with the help of this experiment, he calculated the charge on the electron. Okay, he calculated the charge on the electron, and the charge that he calculated was 1.6 into 10 to the power minus 19 coulomb. So this is the charge that he calculated. So we'll talk about this say Millikan's oil drop experiment later on, but first let us just get to the results quickly. That okay, we got the charge here. Now we are ready to get the mass, so we just put these values here and we got our mass as 9.1 into 10 to the power minus 31. So this is the kind of mass that we have. Now if you just want a more precise value, then the present accepted value of electrical discharge is minus 1.602167, means after decimal we have 6 digits, into 10 to the power minus 19 coulomb. Clear? If you just put this value, you will again get a mass that is also more precise, that is 9.1094 into 10 to the power minus 31 kg. Now for your exam thing and all, I would suggest you that at least you should know the charge up to first decimal also. If you know, that is good. Until and unless it is not given in question, you can use this value. Similarly for mass also, you must be aware that okay, we have 9.1 into 10 to the power minus 31 kg as the mass. Clear? So these are the two important values that you should remember. Being a science student, I think this is very important. Next is characteristics of positively charged particle. Now next comes the positively charged particles. So once all of these electrons were discharged, we provided even more higher voltage, and after that, as we have seen that line that was put there, that was put wrongly there. So this line here, okay, this line, yeah. So if the electrical discharge is carried out in a more modified cathode ray tube, that led to the canal ray. So that is the positive ray that we see after all the negative ray has been discharged. So this is led to the discovery of what? This led to the discovery of proton. Clear? Now again we did that same experiment of electrical and magnetic field and calculated the charge, and of course your the charge came out to be 1.6 into 10 to the power minus 19, so that the electrical neutrality remains balanced. Clear? Now here an important point, the charge to mass ratio depend upon the gas. Initially those were not dependent upon the gas, but here the charge and mass ratio is dependent upon the gas, and we came with a conclusion that okay, there is something that is not only fundamental, but still we need to go more deeper. Opposite behavior to cathode rays, so all the things were opposite. If you just put the kind of potential, then the canal rays move toward the negative charge rather than the positive charge, indicating that they are positively charged. So the smallest charge ion obtained from hydrogen is proton, that was characterized in 1990. Clear? So we'll talk about now this proton. So this is the lightest positive ion, as I've told you. If you just take a hydrogen ion, if you ionize it, put one electron out, you will get a proton. And it was characterized in 1919 by James Chadwick. Okay, in 1932, this particle was discovered by James Chadwick in 1932 by bombarding a thin sheet of beryllium with alpha particles. So we'll talk about this later on in classes. So when an electrically neutral particle having a mass slightly greater than the proton were emitted, okay, and he named these particles as neutrons. So this was about what? This was about neutrons. So if you just take if you just bombard a thin sheet of beryllium with alpha particles, then you will get what? Something that will have what? So something that will have no charge and a mass that will be greater than the proton, and they were termed as neutron, which was discovered by James Chadwick in 1932. Clear? And why this was needed? Because when you calculated the mass of an atom with the spectroscopic method, and you know that okay, these are the number of electrons, and they will contribute to this mass. These are the number of protons, this will contribute to this mass. Now still the mass of atom was in a great deflection with the actual mass that we have calculated through experiment with the help of electron and proton. Means something is missing here. and that must be neutral because electron and proton are already maintaining the electron neutrality, and that thing came out to be neutrons. Clear? Okay. So let us summarize all these particles: electron, proton, and neutron. Symbols are E, P, and N. That is the first letter of the subatomic particle. Charge is 1.60217 into 10 to the power minus 19 in the negative sign, and with the positive sign we have a proton. So they both have the same absolute value, so that the atoms can be kept neutral. If you talk about the relative charge, so we don't take it as every time we take it as -1 and +1, means we took this -1 as a relative charge. So whenever you calculate the charge on anything, then you divide this charge by the amount of charge that is present here, and you get it as the relative charge as -1, and here the relative charge is +1. Talk about the mass. The mass of the electron is 9.1 into 10 to the power minus 31, which is very, very less as compared to the proton and neutron, which are having almost approximately same mass. Now, this is the mass, relative mass, with the help of, you can say, in accordance with the carbon atom, carbon 12 atom. And at last, we have approximated this value to this. Okay. So, this was all about today's class. We have seen these subatomic particles. Okay. With this, I end my lecture. Thank you.